Okay, welcome to lesson 52. So we're going to talk about control charts for continuous quantitative variables. So we're going to introduce the X bar chart, the S chart, and the R chart. Also, we have a special R package, QCC, for quality control charts. So the X bar chart, so it's going to average the average of a process. So we're going to go ahead and take these subsamples over time. And from these subsamples, we're going to take the sample average from each of these subsamples and look at how these subsample averages change over time. So here, when we don't know the values for mu and sigma, we're going to use estimates. So where we're going to start, yes, this is supposed to be X bar bar, or like a grand mean. So if I were to take an average of all the sample averages, what is the overall average here? And then S bar is if I were to take the average of all the sample standard deviations, what is that average? So we're going to have N is this size of the individual subgroups. Typically this will be 3 through 6. You don't want, remember again, to have subsample sizes that are too big, but you also definitely don't want to have it too small. You don't want to take a subsample of only like 1 or even 2. That would be really, really rough. So here we have this X bar bar plus or minus 3 times the sample standard deviation average times this A sub n, and we're going to talk about it in a second, times the square root of n. So A sub n, right here, it's something that we need to use. It's a multiplier that we're using because the expected value of X bar bar is equal to mu, which we want. But the expected value of S bar is not equal to sigma. It's a biased estimate. So we have this multiplier, which is equal to, so we know that the expected value of S bar over this A sub n, and A sub n is going to change depending on what our sample size is unbiased for sigma. So we need this multiplier in there in order to get an unbiased sample, or unbiased estimate for sigma. So basically it's saying that 3 times S bar over A sub n. This will be unbiased for sigma times 1 over root n. That's effectively what we're looking at here. So this is a throwback to, is it week 1 or 2, when we had that gamma function. So that gamma function, remember we were putting numbers like alpha in there. It's a little bit trickier. Absolutely, you can find these in R, find that gamma function, but for a value that's a integer, so if I had gamma of 3, that's equal to 2 factorial. It's a little trickier if you have fractional, like if n is something that's not an even number, it'll be a little bit trickier. But we give these to you. You do not need to calculate them. You could calculate them if you really want to, but typically we're going to just get this, honestly, this constant multiplier that we use from a table. So they're right here. We do not expect you to calculate them. We expect you to just pull them out of this table. This is where they're at. And they're going to, I think, be on multiple slides throughout, if not just this lesson, but lesson, maybe lesson 30. Nope. Just this one, I think. So here we have the following data. We're looking at measurements of force in PSI, so pounds per square inch, that is needed to crack a sheet of plastic, where X bar bar is 30.267 PSI, I would hazard a guess here. And the standard deviations, S bar is going to be 2.323 psi. Establish the lower and upper control limits. So things to look at here. So this is my number of subgroups. So K is equal to 22. Remember, we typically wanted to have at least 20 subgroups, so we should be okay. And then here, we're looking at, this is n, so subgroup 1, I have 4 in my first subgroup. So then I could average from that first subgroup. So that's actually what we're going to do here. So this is the mean from subgroup 1, this is the mean from subgroup 3, and so on. And here are the standard deviations for each subgroup. So if I want to go ahead, like x bar bar is when I average that column. S bar is when I average the S column. So here, n is going to be 4. That's how many are in each subgroup. K is 22. And A sub n, this is just going to be from that table, so 0.921. And this is because n is equal to 4. So throwback right there. That's where it's from. So now putting together, x bar bar is equal to 30.267 psi. S bar is equal to 2.323 psi. So I'm going to do my lower control limit first. That's just going to be x bar bar minus 3 times S bar over A sub n times root n, which is really convenient. N is 4. So that's just going to be 30.267 minus 3 times 2323 over 0.921 times the square root of 4. Do some math here. I get 26.48 psi. So that'll be my lower control limit. So if I'm seeing things below this, this might be some cause for some concern. And then I'm going to do the same thing for the upper control limit, except I'm going to add instead of subtract. So upper control limit, it's going to be x bar bar, but plus. So plus the 3 times S bar over A n over times root n. So here I'm going to get 30.267 plus 3 times 2.323 over 0.921 times the square root of 4. Very conveniently is equal to 2. Sorry, I'm running out of room just a little bit here. So that is going to be equal to 30.05 psi. So that means when I go ahead and I make my my control chart, I'm going to have some center line, but my lower line is going to be at that 26.48. My upper line is going to be at 34.05. So I just calculated where those control limits would be. So here, I'm interpreting an X bar chart, so we want to go ahead look at this. So the first thing I'm going to look at is, here's my control limits. Are my points within here? Yes, I would argue that yes. So all of the sample means, sorry about talking and writing can be, of the sample means are within the control limits. So the process appears to be in control. So, okay, so further, in addition to looking as if it is in control, we would say the average standard deviation of the subsamples is 2.323 psi, because that's what we observed. However, we know that's a biased estimate for sigma, that the expected value of S bar is not equal to sigma. The expected value of S bar over A sub n is equal to sigma. So here we're going to say, hey, the unbiased estimate is 2.521 psi. And where does that come from? R calculates that for us. So that's just that S bar over A sub n. It's right here. This is what R has calculated for us. So interpreting the X bar S chart, so these are two charts put together. They're not necessarily the same chart per se, but having them next to each other. So these guidelines, they were developed by Walter A. Schuhart. So they worked at Bell Lab as an engineer and statistician back in the 20s. And so some guidelines. So remember, in order to use the X bar chart, in order to trust using S bar to create the limits, we need to know the S chart is in control. So 1 and then 2. So if the S chart's not in control, you don't want to use the X bar S chart. There is also an X bar R chart. We tend to use R less often than S, but we'll talk about that. So look out for runs. So this is where you have like streaks of increasing or streaks of decreasing. So increasing streaks or decreasing streaks. That would give us a cause for concern that maybe something's happening. So absolutely, if you have 3 or more successive points that are increasing or decreasing, so remember not to necessarily count the points of inflection where it's changing, but like, so I'm increasing, that's like 2, decreasing, that's 2. That would be something. 8 or more successive points that are above or below. So absolutely, if we have a lot of points that are above all of a sudden or below, it indicates that maybe the process has shifted up or down. This is definitely a good reason to stop and look at the process, troubleshoot. So each industry, they might have their own protocols. So they might decide, you know what, 3 or more successive points decreasing or increasing, that's a concern. They might say, you know what, 8 or more successive points above or below, that's too many. Maybe we want to stop if we have 6 or more. That kind of idea. So then last, definitely the least commonly used nowadays that I know of, we have the R chart. So it monitors the range. So if I took these subsamples and calculated the sample range for each of them, how is that range changing? So the max minus the min of the subgroups. And they use it along with the X bar chart. So you can have an X bar R chart. So instead of using the sample standard deviation to calculate the control limits, you use R. It's a lot less common to use. So it's very outdated. S chart is preferred by most folks. And it has to do with like what was available, computing power, all of that, back in the day when this was designed. Some will argue that our chart's better than the S chart when our samples are really small, but a lot of times the difference is they're not really a big deal. So most of the time we won't pick an R chart if we have an S chart at hand, but know that you might see these are out there. They're just kind of old school. And so we will join you for when we look at discrete and categorical variables next.